Hello, Greg.
Hello, how's it going?
Good. How are you doing today?
Doing well.
Good.
All right.
Send me something, or are you going to verbalize?
Yep. I'll send you some stuff.
Huh?
Send you a whole page. Let's see where'd it go? I just had it. There it is. All right. So we're doing rates of change, instantaneous, and average rate of change.
Okay.
I don't need to work through the entire worksheet. Just a good portion of this. Same email as last time.
I'm sorry. Yes, David Cowan, 1949 at gmail.com.
All right, it is sent. Hopefully, it sends fast.
Yep.
Sweet.
Rates of change. The difference between calculus and algebra is all about average rate of change. Calculus is generally about instantaneous rate of change. Okay.
All right.
Where do we want to start here? We want to start.
So I number one, I'm fine on. I started getting. Oh, let's see where. I started getting fuzzy. Let's do number 4. No, let's do number 3 actually.
Okay. All right. The slope of the tangent line is going to be what?
It's going to be the same thing as the instantaneous rate of change.
Yeah, it's the first derivative of that function. Well, first of all, tell me how far you've gotten on first derivatives. Have they taught you the power rule yet, or are you still doing?
No, she hasn't even mentioned derivatives yet once.
Really?
Yeah.
Well, here's the problem. There's the curve.
Mm-hmm.
They want to know what the slope of the tangent line is at 7. In other words, what is the slope of that tangent line?
Mm-hmm.
That's what calculus is all about, derivative calculus.
Okay.
Now, here's the problem. They teach calculus just like they teach every other math, which is to say they give you the hardest part first. Never have understood this, but that's what they do. In other words, if you want the slope of the tangent line, then you are taking the limit of f of x plus h minus f of x all over h as h goes to 0.
Yep.
That is the limit quotient definition of first derivative. And this is probably the hardest thing you're going to deal with in almost all of differential calculus. And they make you deal with it right at the beginning. And what it really is just hard algebra. That's all it is. So
Yeah.
I'm assuming that this is the method they want you to use. This is the only one they've taught you at this point.
Yep. That is correct.
And so let's figure out what is always start by figuring out that. So tell me what h of x plus h is.
So would that be?
These h's just happen to be the same. In other words,
Okay.
it'd be just as easy if this was called f of x, and what we're really looking for is f of x plus h.
So would it just be f? Or no? So would you substitute? So you were substituting in the x plus h. So which it wants it at 7, right? So I'd be substituting the 7 in for x. So it'd be 7. So it'd be 7 plus 8 minus 3
There
underneath
is
square root.
another. There are actually two definitions for the slope of the tangent line. The other one is this one. If you're trying to figure out the slope of the tangent line at a specific point, this one can be used.
Okay.
And might even seem easier. It probably is in this situation. We'll go through it. But this one over here on the right is far more robust. This one on the right gives you the derivative function. This one on the left gives you only the slope of the tangent line.
Okay.
Now, which one are we to use? Do you know? Because they want you to specifically use that one.
I don't know. I don't know if we've even. I think we learned the one with the a. I think a little bit today, but I think this homework we're supposed to use the
one on the right.
Yeah, the one on the right, I believe.
Okay, let's do it. The one on the right then. I like the one on the right to the extent that I don't even like using the one on the left. There is never a need to use the one on the left. And the reason there's never a need is because the one on the right handles all values. Once you get the derivative function, then all you do is plug in the value for x and you got your answer. Whereas the one on the left works for one value only at x equals 7. So if we do the one on the right, h of x plus h is square root of x plus h minus 3. H of x is square root of x minus 3. And so if we're doing the one on the right, then we want, and tell me if this bothers you, I don't have to write on top of other print here. I can open up another page and write on that. In fact, I tell you what, let me just write on this blank area up here on the right. You don't need that picture anymore. You know what we're doing. So what I'm going to do is the limit of square root of x plus h minus 3 minus square root of x minus 3 all over h as h goes to 0. Now that's just a hard algebra problem. And that's why these are so tough. And once I'm going to give you a little secret. Once they teach you the easy way to do these, you'll never use this way again.
Okay.
This is definitely the hard way to do it. And the goal is to figure out what that limit is. Well, let's see. A good way to do this. How about if we multiply, let me think for a moment here. Whenever you see radicals like this, you generally want to multiply by the conjugate.
Yeah.
Okay? So I want to multiply top and bottom by the square root of x plus h minus 3 plus square root. Hold on. I want to multiply top and bottom by x plus h minus 3 plus square root of x minus 3. I'm going to multiply top and bottom by that.
Okay. So in class, she had us substituting in x 7 for x. She had us substitute in the value for x. So is it better to leave x as x until the very end and then substitute it in?
It depends on which way you're doing it. If you're doing this by the standard limit quotient definition, which is f of x plus h, this is the way we want to do it. If we're doing it by the f of x minus f of a, that'll get us to the answer a little quicker, but it's not the best way to do it. Let's do it both ways. You'll see.
No, wait, we do it this way in class, but instead of leaving x as x, we always substitute in whatever we're trying to find x as. So we're trying to find x at 7.
That's not the way we do it if we're trying to find the derivative function. You'll see what I mean.
Okay.
If I multiply the top by the conjugate, then most of the square roots disappear. The left side becomes x plus h minus 3. And then it's difference of squares, so that is minus x minus 3. And the bottom is just this correct? With me?
Yeah.
Now remove the parentheses from the top and you will notice that everything that does not have an h in it disappears. That disappears, that disappears, that disappears, and that disappears. And that always happens whenever you do this method. Okay? So what you end up with is h alone in the numerator. In the denominator, we've got square root of x plus h minus 3 plus square root of x minus 3, all multiplied by h, meaning the h's can cancel. In other words, this becomes much like a limit problem, and this is our derivative. Now substitute h goes to 0, and you will not get 0 over 0. Notice that as you substitute h goes to 0 here, you get 1 over 2 of these things. You get 1 over 2 times x minus 3. That is your derivative function. And now if I want to figure out the slope of the tangent line at any value of x you want to give me, I can do it. In other words, we want to figure it out at 7, substitute 7 for x, we get 1/4.
Oh, okay.
So the slope at 7, now here let me erase just a little bit more. I don't want to erase my answer. That's an important answer. And by being robust, what I mean is that now we can figure out the slope of the tangent line at whatever x they want to give us. Remember when I drew that graph, it was sloping, so the slope of the tangent line changes.
Mm-hmm.
In other words, I drew the graph. It's the square root function, 3 spaces to the right. So notice that at 7, the slope of the tangent line is like that, but at 10, it's much flatter.
Mm-hmm.
That's why this is the best method, because this is more robust. If I want to know the slope of the tangent line at 7, then I take h prime evaluated at 7, which in this case gives you 1/4. Now, determine the equation of the tangent line at 7. Well, what do you need to determine the equation of a line, especially in calculus?
Yeah, I don't know.
Point slope. In other words, in algebra, the first thing they taught you was slope intercept, y equal mx plus b.
Mm-hmm.
But turns out that's not the best one. That's just one form of a straight line. Well, we're talking about a straight line. The equation of a line tangent, that's a straight line. This doesn't work so great in calculus. You could use it, but what works an awful lot better is point slope, which is this format. And the reason it works so much better is because you almost always have a point and a slope. When you take the first derivative of a function, you get the slope. That's what it is. We just took the first derivative of that function, and what we get is this function. So the points are, well, I need a y sub 1. Well, when x is at 7, h of x is 2. So here's the equation of my tangent line. Bingo. Done. You do not want to turn that into y equal mx plus b. And in fact, this is the superior format when you're talking calculus.
So y1 is just putting it. You plug in 7 for x into the equation.
You have to figure out what h of 7 is, and h of 7 was 2. That's what y is when x is equal to 7.
Okay, so square root of 7 minus 3, which is root of 4, so that's 2. Okay, all right, I'm tracking.
Okay. Now, I'm going to recommend we do all of them this way and this way only.
Okay.
Well, before we go on, let's just give it a shot. F of x minus f of a all over x minus a as x goes to a. Well, let's see. F of x. So here, let me erase some of this stuff. I want to erase all of it. Well, we already figured out that. I don't need that. I'm going to leave that function down there. So, f of x is square root of x minus 3 minus f of a. Well, that's f of 7. So that is 2 all over x minus 7. And I want the limit of this thing as x approaches 7. So there's the other way to do it. And as all that's going to give us is 1/4 for an answer. In other words, that's just another method of getting what this is when x equals 7.
So it just applies to those singular point. If you want to do another point, you have to write the whole equation again. So it's just
so
okay.
what ends up happening is once you do this once or twice in your life, you never do it again. You always go to the f of x plus h minus f of x, and that, because that gives you an answer that's a function. This answer down here will tell you the slope at any x you want to give me. If I do it this way here, I'm only figuring out the slope when x is equal to 7.
Okay.
Now, this problem right here is just a limit problem. We'd do it the same way. I would multiply top and bottom by the conjugate. I would figure out which cancels, and I'm gonna discover that as x goes to 7, this whole thing goes to 1/4. So I don't honestly think it's worth the time doing that method. I definitely understand why they want you to know how to do the limit quotient method. So I'm going to suggest that as we go through these, we use the limit quotient method on everything.
Okay.
In other words, the limit as h goes to 0 of f of x plus h minus f of x all over h. That always gives you the function that is the first derivative function. So let's try it on this one. So,
okay.
First of all, tell me what the way you do these is you always start out by listing what f of x plus h is.
All right. So f of x plus, so it'd be f of 2 over x plus h minus 3.
Right. So that's this thing. So in our numerator, we have 2 over x plus h minus 3 minus f of x, which is just 2 over x minus 3. This is the limit problem we need to solve. This will always give us our derivative function. And then we can go from there. In other words, they want to know what the slope is at minus 2. Once we have our derivative function, we'll plug in minus 2 for x and we'll have our answer.
Yeah.
The difficulty with these limit quotient definitions is the algebra is kind of brutal.
Yeah.
But not really. Once you kind of get used to it, how do I handle this numerator?
I probably conjugate, I'm sure.
No, actually. Think of the conjugate when you're looking at radicals. But if you're not looking at radicals, all I got to do is subtract these two fractions. So how do I subtract fractions?
Common denominator.
What's the common denominator going to be here?
Oh, geez. Would that be...
Don't multiply it out, ever. In other words, this is the common denominator.
Oh, yeah, that's right. So you have to multiply the entire...
Don't ever want to multiply it out.
So you multiply the numerator of the numerator and the denominator,
exactly.
Correct?
And you'll find out, as in all of these, that whatever is in the numerator, anything without an h in it's going to disappear. So first of all, what goes right here in the top left?
That would be, so it's 2 times x plus h minus 3 times x minus 3.
Actually, hold on. One of the reasons you don't multiply the 2 on the bottom is to make sure you don't make a mistake. Is that the same as that?
No.
Yeah, you just cancel the x minus 3 over this x minus 3, and I got
Oh yeah,
what
it is.
I started with. So
Oh
that's
yeah.
one of the reasons you don't multiply out the bottom, is so that you
Mm-hmm.
can just make sure. Now over here on the right, we've got the x plus h minus 3. With me?
Yeah.
Okay. Now simplify the numerator, gives us 2x minus 6 minus 2x minus 2h plus 6. And that is all over its common denominator. In other words, this isn't really hard algebra. You just have to know how to do the algebra. So that's my numerator. With me?
Yes.
Okay.
Hold
Now, what did I say about the numerator of the numerator? Everything without an h will disappear. That 2x cancels. That 6 cancels. The only thing I have left is minus 2h in the top. So I
on.
have minus 2h all over x plus h. I still don't multiply it out, ever. I don't have a need to. It's easier to solve the problem if I don't multiply these things out. All over h. Now notice what happens. The h's cancel.
Mm-hmm.
Final answer. Here, let me figure out how to write this. The only thing I don't like about writing on top, I don't have enough room, especially with calculus. So my final answer is minus 2 over x plus h minus 3 times x minus 3. What's the limit of that as h goes to 0?
So that's -2 over. So that's x plus 0 minus 3 times 0 minus 3. So
X minus 3 squared.
yeah.
That is your derivative first, your first derivative function.
Okay.
Now, if you want to know what that does, when x goes to minus 2, plug in minus 2 for h. You have your answer.
Or for x.
For x.
Oh yeah. Yeah. Okay.
I'm sorry.
All right.
Okay. Now, so hold on a second. Let me erase everything except that function, because I'm going to call this function, the original function was f of x, so this has to be f prime of x. That is the derivative function. I heard a really good explanation for calculus once. Let me give it to you. Arithmetic is the manipulation of numbers. Algebra is the manipulation of letters that represent numbers. Calculus is the manipulation of functions. We started with this function here. The first derivative is this function up here, f prime of x. That's what it means. And now if I want the slope of the tangent line anywhere, I just plug in minus 2. So if I want f prime of minus 2, what's that give me? Minus 2/25.
Mm-hmm.
Now, the second part of that question, determine the equation of the normal. Well, I'm still going to use point slope. I always am using point slope. I'm never using slope intercept anymore. Because when you do calculus, what you end up with is the slope and a point. Well, I just figured out what the slope is. Minus 2/25. So what's the point? X is minus 2. What's y when x is minus 2?
-2. Wait, no, negative 2 over -2 over -5, so -2/5.
Okay. So there's my point. There's my slope. Using point slope, what do you get?
So it would be, so that's y minus 2/5 equals.
Hold on. It's y minus a minus 2/5. Which
Oh, yeah, so plus
2/5
equals -2 over 25 times x minus -2, so +2.
That's the equation of the tangent line. Now,
And the normal line is the inverse of that.
Equation of the normal line.
Isn't that just the inverse?
Not the inverse. What's the slope of the normal line?
It's the opposite reciprocal.
Okay, so what is it? If the slope of this line is minus 2 over 25, what's the slope of the normal?
25 over 2.
Now, we use that slope. Our point is exactly the same, so all I have to do to this is make it 25 over 2.
Okay, so one question about like the opposite reciprocal is you flip it over and you just take the negative sign away.
Yep, no, switch signs. You have to do two things.
You switch signs.
You reciprocate it and you switch the signs. Always. Both of those things you have to do.
Always. All right, cool. All right, so that helps on that.
Now, the next one's actually a little easier. Now, you're sure that you have not learned the power rule, right?
Nope.
I'm going to teach it to you right now.
Okay.
Start with the exponent, subtract 1 from the exponent. That's the derivative function.
What?
You didn't hear me wrong.
So you're given...
You multiply that times the coefficient to get 3, and then you subtract 1 from the exponent. So if I told you f of x equals 5x to the 4th, tell me what the first derivative of x is.
So it'd be 20x to the 3rd.
That's as simple as that.
Wow.
Yes. Wow is correct. It's beyond me why they don't teach this first.
Yeah, that's ridiculous.
It is ridiculous. Because if I have to do this the way we've just done the first two problems, then I got to figure out f of x plus h. I got to subtract f of x. I got to go through all the algebra. I'm going to still come up with this exact function. I'm just going to have to do a lot more work. Okay. Now, the ones that are really tough to do are ones like this, where there's a radical sign or it's a quotient. The ones like this aren't that hard. To figure out, first of all, what g of x plus h is a piece of cake. And
so
there's no hard algebra. I don't have to multiply by the conjugate. I don't have to find a common denominator. I just got to simplify it. And my answer will come a lot quicker. So using what is called the limit quotient definition, that's the f of x plus h, it's not so hard on polynomials. It's just really hard on problems like that one and that one. So I'm not quite sure why they put them in the order they did. They gave you the hardest one first, then the next hardest one, and then the easiest one. Now,
so how would you use the?
Well, let's just do it the easy way first, and you're going to just be shocked at how much easier it is.
Okay.
So, and I'm teaching it to you because they're going to teach it to you. The next time we talk, they will have taught you the power rule. It's coming immediately. Okay? So if you're going to apply the power rule to a polynomial like this, you can apply it to each term.
Mm-hmm.
Well, the derivative of a number is 0. So g prime of x is 0 plus 2 minus 2x. Bingo. What is g prime evaluated at 5? Well, looks like 2 minus 10 or negative 8. See how much faster I can do them?
Yeah, that's much easier.
Slope at 1. That's g prime of 1, which is 2 minus 2, which is 0. So much easier with the power rule. Now, the power rule does not handle all functions. If I said to you f of x equals x times sine x, well, now I got to apply something called the product rule because I'm multiplying this polynomial times this trig function.
Mm-hmm.
So there are 4 rules that will handle all of differential calculus, and that is the power rule, which you've already learned, then the product rule, which you use whenever you're multiplying 2 functions, then the quotient rule, which you would use if you were dividing 2 functions, and then the chain rule, which you'd use if you have a composite function, something like this, all to the 4th power. That's the chain rule. They will teach you those 4 things next. Once you learn those 4 things, you will be able to differentiate every single function you come across, and you will never ever have to go back and use this silly quotient formula. That's the truth of the matter. Once you get by the first 2 weeks of this, where they teach you this limit quotient definition, you never ever go back to it. Who would? It's the hard way to do it, not the easy way. These power rules and product rules and quotient rules, those are relatively easy. I'm not going to teach them to you today just because we're not quite there yet. And I guess there's a reason why they want you to do all of these the hard way. We'll do number 5 the hard way just so I can show you that it's not really that much harder than the power rule. So tell me what f of x plus h.
F of x plus h?
On number 5.
That would be, let's see here. So f of x, so it would be 24 plus 2 x plus h minus x plus h squared.
Remember, what we're doing is subtracting from that, and parentheses are extremely important here. I need parentheses desperately. I'm not going to get the right answer if I don't put them in. I'm subtracting f of x. All of that goes over h. Now all you have to do is expand the top. And you don't even have to worry much. Remember I said everything that doesn't have an h in it's going to disappear. So that 24 is going to disappear. That 2x is going to disappear. I'm still going to have a 2h. This, I'm going to have a, let's see, in the middle there is plus 2xh. So that becomes minus 2xh. Plus h squared, which becomes minus h squared. These 3 terms all go away. In other words, they're taken out. When you expand those, you get the opposite of each of those 3 terms. Okay? With me? Did I go? Did I skip too many steps?
No, I think we're good.
Well, let me just do it real quick. I'm going to expand this top out here. So I get 24 plus 2x plus 2h minus, in parentheses, x squared plus 2xh plus h squared, and then I'm subtracting f of x, which is 24, plus 2x minus x squared. And what I said is that everything without an h is going to disappear. Well, that 24 goes with that 24. That 2x goes with that 2x. That x squared goes with that x squared. What are you left with? That term minus that term minus that term. That's what I've got in my numerator. In my denominator, I have an h. Well, notice now I can divide top and bottom by h, giving me 2 minus 2x minus h. What I want to do is find the limit of that as h goes to 0. Well, what is that? 2 minus 2x, right? Power rule, I got there in 5 seconds. Apply the power rule to that, you get 2 minus 2x.
Wow.
I laugh because your reaction is so logical. Why are they teaching us this horribly difficult method when they could teach us this simple method? I do not know. I do not know. It's almost like they're trying to intimidate you into not taking calculus.
Yeah.
So here's my function, 2 minus 2x. Well, I can evaluate that at x equal 5 really easily. That's equal to minus 8. That's the slope. At x equal 1, it's equal to 0. A 0 slope is a horizontal line. Graph that on your calculator. It's going to be a parabola. It's going to be a parabola that looks something like that. Okay? Now the question is, does the slope of the tangent line at x equal 1 make sense? Well, there's x equal 1. The slope of the tangent line, we figured to be 0, right?
Yeah.
And it is. It's always 0 at the vertex of a parabola. The slope of the tangent line is always 0 at the vertex of a parabola. Always.
Okay.
Now, they said graph the line y equals 25, which is just a horizontal line like that at 25. Now, what would that be? It'd be 24 plus 50. Oh, no. No, we don't know what x is. So I'm not sure why they ask you to graph the line y equal 25, other than the line y equal 25 also has a slope of 0. It's a horizontal line.
Oh.
So that's probably why they want you to do that. It says then graph the line y equal 25. That's a horizontal line way up here. And what our parabola will look like, well, we know 1. What's y when x is 1? It looks like 25.
Yeah.
So that's why they're doing it. The graph of 25, y equal 25, is that slope, is that tangent line.
Okay.
So why does the tangent slope make sense at x equal 1? Because that is the vertex of the parabola, and the slope of the tangent line is always 0. when you're at the slope or when you're at the vertex of a parabola. And that's where y equal 25 is the vertex. If I put coordinates right there, it's going to be 1 comma 25.
Okay.
D, determine the slope of the tangent line to f at x equals a. Well, what would it be? 2 minus 2a.
Mm-hmm.
That's the answer.
Oh, okay. That's easy
Now,
enough.
well, they probably want you to do it the other hard way. And again, this makes even less sense to me. There are two definitions for first derivative. One of them is the f of x plus h, but the other one is f of x minus f of a as all over x minus a as x approaches a. So if you did it this way, you'd still come up with 2 minus 2a. It's just that by using the more robust method, I came up with the derivative function, and now if I want to know what the derivative function is when x is equal to anything, I just plug it in. So they're saying, what is it when x is equal to a? Well, instead of 2 minus 2x, it becomes 2 minus 2a.
Okay.
And I would get the same thing if I did it this way. It's just, to me, this is the worst way of all. It's still hard because you got to do all the complex algebra. And it only gives you the slope at one point, a. It does not give you the derivative function. And it's the derivative function that we're really interested in. We want to know what the slope of the tangent line is anywhere. If I draw a function like this, why is it so key to know the slope of the tangent line? Because where are the key points on this function? Right there, and right there, right? I want to know where that happens, because that point right there gives me the maximum value for the function. So if you tell me what this function is, I'll apply the power rule, come up with the slope of the tangent line, set it equal to 0, and it will locate that point, and that point. And those are the kind of points you're always looking for, is where you're looking for relative extrema. This is called a relative maximum, that's a relative minimum, and that's a absolute maximum. And those are what we're looking for in calculus. We always want to know where's the maximum value of that function, and you can be sure that it's where the derivative has a 0 slope. You cannot get from there to there without having exactly one point where the slope of the tangent line is exactly 0.
Okay.
Okay. Now, I'm not going to get beyond the power rule, just because that gets a little more involved and we don't have enough time to go into that. But the power rule is a great way for you to, even if they're forcing you to do this the hard way, in other words, if they say use the f of x plus h method and show all your work, well, knowing the power rule is going to be helpful because you can instantly figure out that that is 2 minus 2x. So we know what the answer is, it's that. So when you do it the hard way, if you don't get 2 minus 2x, you've made a mistake.
Oh, okay.
So that's the advantage. That's why I'm telling you about the power rule. It's because it's pretty helpful to have. Now, let me just do one thing about the power rule. What's the derivative of that by the power rule method?
So the top is 0.
Now, hold on. First, you got to write it like that.
Oh, okay.
Now,
So you
start with the exponent.
times the coefficients,
By 1.
-2 times 1.
Subtract 1 from the exponent. That's your answer. If they want it back in this format with a positive exponents, that's my answer. So it gets a little tricky when you have a negative exponent. Not really. You still start with the exponent, multiply it by the coefficient, and subtract 1 from the exponent. The power rule is as straightforward and simple as you're ever going to discover in calculus. There's almost nothing easier than the power rule. But I wanted to point out that when your variable x is in the denominator, you got to make sure you get it to the numerator before you apply the power rule. And in order to do that here, you got to put a negative exponent on it.
So what if the number on top was something else besides 1?
3. Okay, now I multiply -2 times 3 to get -6. And subtract 1 from the exponent, and I got -6 times x to the -3rd.
Oh, I see now. Okay.
Okay. In other words, you're always starting with that exponent, multiplying it by the coefficient, which in that case was 1. But in your case, it's 3. So -2 times 3 gives you -6. Then just subtract 1, you're done. And usually you don't really want to put it back in that format there. And the reason is that exponents are so crucial to calculus that you don't want your variable in the denominator. You always want it in the numerator with a negative exponent. It makes getting into the power rule that much quicker. You can instantly apply the power rule. If I tell you this, give me the derivative of that.
Be -12. No, 12 to the -7th. 12 times x to the -7th.
To the -7th. And that's a good answer. I wouldn't even bother putting that x in the denominator because the very next step take the second derivative of it. And what would the second derivative of it be? -84x to the -8th. First and second derivative, power rule only, piece of cake. If you had to do this problem using their limit quotient definition and you had to do it twice, I'd still be working on it 20 minutes from now.
Yeah.
Just because the algebra would be so hard.
Mm-hmm. Okay. So can we go down to a lower problem on the page?
Sure.
The only problem that I actually need help with would be 10, I think. Maybe 9 and 10 if we have time, but 10 more so, I think.
Okay. Well, 9's so easy, especially if you don't mind me using the power rule.
Mm-hmm.
So I'm going to do 9 first. We'll do both of them. But 9, I want you to understand 9. This is a very, very common problem. The height of that object is 100 minus 4.9t squared. And this is not a function of x, it's a function of t. Okay? So, how fast is the object falling? Well, first derivative is velocity. If height is position, first derivative is velocity. So velocity of t, which is h prime of t, in other words, velocity is the first derivative of the height, Going to use the power rule real quickly, 9.8 times t. There's your velocity at any point in time when that thing is falling. So if they want to know how fast the object's falling 3 seconds, what do?
3 times negative 9.8.
Correct? Which is what? Minus 29.4. And the reason it's minus is because it's going down. When you talk velocities, velocities are vectors. So not only do they have a number attached to them, a scalar quantity, but they have a direction. And the negative sign tells you it's falling, not rising. If we're launching a rocket ship into the sky and they say, what's its velocity 2 seconds after liftoff, it's probably going to be positive because it's probably still going to be going up. But I don't know if they've taught you that velocity is first derivative of position.
No, they've never even mentioned the word derivative yet.
Okay. It's interesting how they're doing these. Okay, let's take a look at 10. What's the rate of change of the area of a circle with respect to its radius when the radius is 2 inches, 5 inches, and 10 inches? Well, we need a master formula. Remember, calculus is all about manipulating functions. So the area of a circle is what?
Area of a circle is pi r squared.
Well, when they say the rate of change of the area, they mean a prime as a function of r. What is it?
So using the power rule.
Uh-huh.
So 2 times pi times r.
Notice that is also the circumference.
Mm-hmm.
And that's not accidental. So now, what's the rate of change of the area when the radius is 2 inches? That means a prime of 2 equals what?
2 times pi times r.
Times 2. R is 2.
Times 2.
Okay? So the rate of change is 4 pi. That means the area is increasing by 4 pi per whatever time frame they're asking about here. They're getting pretty deep into calculus without ever having mentioned what derivative is. Okay, now how about what is the rate of change of the area at 5 inches?
10 pi.
And at 10 inches?
20 pi.
Simple as that. Now, hold on a second. Don't use the difference quotient 3 times. Yeah, because you'd still be working on it tomorrow. Use it once. So they didn't want us to use the power rule. They wanted us to use the difference quotient on this function.
I think that they wanted us to use the difference quotient to find that.
Right. And only once. In other words, the difference quotient is going to give us that as an answer, 2 pi r.
Yeah.
Once you have 2 pi r, now just set x equal to r instead of x equal to a. It almost looks to me like this whole page was designed to use the f of x minus f of a definition. Not so much the f of x plus h minus f of x, which is the more robust definition.
Yeah.
Doesn't really matter because I'm going to almost say they're never going to go backwards. You may end up getting a test, though, at the end of this section where they want you to use the f of x minus f of a, and they also want you to use the f of x plus h minus f of x, both of them. So you may be responsible for knowing how to do both of those methods. They just don't want you to use the f of x plus a on that problem, and they specify that right there. instead of x equal a.
Okay.
Okay? But trust me, the f of a definition is never really needed. You can always use the f of x plus h definition. That gives you the derivative function, and then you can always figure out what its value is at any value of x. So there is only one use for the f of x minus f of a function, and that's the proof about cusps and corners. If I have a function that goes like this, it is not differentiable at that corner. And the way you prove it is by using that f of a minus f of a, or f of x minus f of a definition. And that's the only place I know where that is used. And it's merely used to show you, remember, derivative is slope. Well, that slope might be minus 1 going into that point, and it's plus 1 coming out. Well, what is it right there? It looks like it would be 0, but guess what? It isn't. There is no slope of the tangent line there. Whenever you have a cusp, something like that even, you cannot differentiate it at that point. There is no slope of the tangent line. There is no tangent line. Would the tangent line be that? Would the tangent line be that? Would the tangent line be that? There is none. Kind of the same reason that for a limit to exist has to be the same from the left as it is from the right. And you can see that the limit from the left is minus 1, the slope from the right is plus 1, therefore there is no tangent line at that corner. Other than that, I have never ever had to use the f of x minus f of a definition. Because it's not as valuable as the f of x plus h. Had to do that with every single calculus student because that's the way they start all calculus students off. They start with limits and then they go to the limit definition, the limit quotient definition. Automatic. Automatic. And then they go to the easy ways, the power rule, the product rule, and the quotient rule, and the chain rule. Not that they're that easy, but they're 10 times easier than that stupid limit quotient definition. Greg, you good to go?
Yep, I'm good to go. Thank you very much.
You're welcome. Talk to you next time. Bye-bye.
Talk to you next time. Bye.